Hello everyone, I would like to explain about Naive-Bayes algorithm, clustering and visualization using SAS Enterprise Manner for a coarse dataset. So now let's look at the data. The dataset contains 1728 observations and 7 attributes. The target variable is class, which has got 4 values: acceptable, unacceptable, good and very good. The other parameters are buying price, maintenance price, number of doors for the car, number of persons that can be fit in the car, the luggage, boot size and safety. Now let me proceed to SAS Manner. Let me first explain about clustering and visualization. I've imported my data into SAS using file import. You can see my variables here under the variables tab, variables. These are all the variables that have been imported. Now let me go into the explore tab to select the clustering, drag the clustering over here, make a connection. There are a lot of variables in the clustering tab. We can leave it to default for now, and I am making the specification method to be automatic, which develops a hierarchical clustering. Now let me select this cluster and run it. Now the run has been completed, so let us look at the results. Here we can see that there are 3 clusters. The segment plot explains about different classes. The mean statistics have been populated for all the 3 clusters that are available. Now let us look at the output tab. In the output tab, we can see the eigenvalues for the covariance matrix, cluster history, and the candidates for optimum number of clusters. We can also see the root mean square, total sample, standard deviation, it's 0.4. Now I have selected the segment profile from the Access tab. You can see it from over here. Let me click and run it. Now let's see the results. The segment profile gives us various statistics like variable worth and profile of the segment. Here you can see that the variable worth has been populated for all the 3 clusters that are available. Now let us look at the profile of the segments. Here you can see that the profile has been generated for all the 3 clusters. The inner circle explains about net distribution of variables, and the outer circle explains about distribution of variables for that particular segment. Now let us move on into Naive-Bayes algorithm. I have added a data partition tab, a control tab from the sample and utility tabs. Now I have added a Bayesian classifier from the HPDM tab over here. Now let me select the HPDM classifier. When it comes to the network model, I am selecting the Naive-Bayes model, and we have other different parameters over here like significance level, independent tests, missing interval variance, and all those things. Now let me put all these things to default and let me run this model. Now let us look at the results. Now let us look at the output of Naive-Bayes algorithm. Naive-Bayesian statistics gives a different group of statistics over here, which includes score rankings, variables in the network, fit statistics, and a graph of the Bayesian network. Now let us look at the output. The output contains a classification table where acceptable is classified as acceptable, unacceptable is classified as acceptable, and other things over here. The accuracy of this training and validation data set is 77.3%. Coming to the 5 concepts that were discussed in class, my first concept is to calculate the accuracy of the model basing on the confusion matrix. If you see the confusion matrix over here, I have taken all the diagonal elements that the element have predicted correctly, that is very good as very good, acceptable as acceptable, and I have divided it by total number of observations. So it has given me accuracy of 77.7%. My second concept is about neural networks. In neural networks, once you select this optimization, there are a lot of parameters over here. The ones we are concerned about is learning rate and momentum. Learning rate decides on how fast a neural network adjusts to the errors, so it should not be too high. If it is too large, the problem is that the weight keeps bouncing or oscillating, so it should be maintained at an optimal rate. And the momentum decides how often a neural network can move on in the same direction when you are working on the errors. So it is better that both learning rate and momentum should be kept at an optimal range. They should not be too high or too low. Third concept I would like to discuss about is clustering. I have made 2 clusters over here. And when I click on these clusters and I've selected the specification method to be user specify, so that I can input how many number of clusters I want, and this gets converted into k-means clustering. So I have selected 4 clusters for the first one, and for the second one I have selected 10 clusters, and I've run both of them, and I've collected the results into an Excel sheet over here. I could see that the average root mean square standard deviation for 4 clusters was 0.48, and the average root mean square standard deviation for the 10 clusters was 0.43. This root mean square standard deviation is very much similar to standard sum of square errors. As sum of square errors decreases with increase in the number of clusters, the same has been evident from the root mean square standard deviation. As the number of clusters has increased, the value has decreased from 0.48 to 0.43. The fourth point I would like to discuss about is the relationship between leaf size and accuracy of training and validation datasets. I have selected 2 decision tree source over here. For one decision tree, I have made the leaf size to be 50, and for other decision tree I have made the leaf size to be 5. I have run both the decision trees. I've captured the results in an Excel. So if you see, for a decision tree with leaf size 5, the accuracy of training was 92% and accuracy of validation was 90%. For a leaf size of 50, the accuracy of training was 85 and the accuracy of validation was 83. So when you observe, when you decrease the leaf size from 50 to 5, the accuracy of training and validation datasets has increased considerably. But if you keep decreasing the leaf size, say 1 or 2, the accuracy of the training dataset would increase, but the accuracy of the validation dataset would obviously decrease. This is because of the concept called overfitting. Let me explain it with the help of a diagram over here. So if you consider decrease in leaf size on x-axis and error rate on y-axis, when you keep decreasing the leaf size, the error rate and the training data set would keep on decreasing, but the error rate in validation data set would increase, saying which says that the accuracy of validation data set would decrease with the decrease in the leaf size. The next concept I would like to explain about is the relationship between pruning and significance level. Pruning is to remove certain nodes in a decision tree to improve the accuracy. I have given a significance level of 1.0 for one decision tree and 0.5 for another decision tree. So let us see how it has impacted the tree depth. For 0.5, the tree depth was 4, and for 1, the tree depth was 6. So as the significance level decreases, the depth of the tree decreases and pruning increases, helping in increasing the accuracy.